Okay, so before we start, I'm going to ask y'all to get a pen and a printer if you have one. So, because we're gonna need to print out a test. So, yeah, this is our plan. We're gonna do a little bit of practice and then we'll go over a few concepts and then finally we'll do practice or if you want Q&A. In a typical UIL or number sense test, you have 80 problems and 10 minutes to solve them. You have no calculations on paper, and calculators are not allowed. All work must be done mentally, and you earn 5 points for a correct problem and lose 4 points for any skipped or missed problem until the last problem you do. Problems marked with an asterisk, which is every 10 problems, means that you only need to be within plus or minus 5% of the real answer. You can't cross out answers and write a new one, so if you make a mistake, you have to go on. You have to use a pen. Okay, so I'm going to send a link to what you need to print and I'll set a timer, so make sure to get a pen ready. If you click on that, it'll lead you to this page. Get someone to print it or wait 2 minutes for people to print, and then I'll start the timer. 2 minutes to get a pencil, to get a pen and print. Okay, has everyone printed it and gotten a pen? Okay, then I'm gonna start a timer. Remember, you can't make any additional calculations. Start at 3, 2, 1. 2 minutes left. One minute. Time. Okay. So we're gonna check answers now. So what you want to do is you want to multiply the last problem you attempted. So let's say if you attempted problem 40, then you multiply that number by 9. Then you subtract the number of ones that you missed or skipped by, like, you multiply the number that you attempted by 5. Then you multiply the number that you skipped or missed by 9. So let's say if you got 40 problems and you skipped 2, missed 5, that means you get 40 times 5 minus 7 times 9, and that's your score. So just check your answers real quick. The ones marked with an asterisk means that your answer can be anywhere between those. And once we're done checking, just tell me your score and skim the rest of the problems to see if you have any questions. If you want to check the answers for yourselves, I've also posted the link. Okay, has anybody not finished checking? Because if you haven't, I'll move on. I mean, because if everyone's done checking, we can move on. Okay. If you have any questions regarding this at all, you can tell me. Make sure you understand what we do in these and why, because I think that's a really important aspect of number sense. And if you do know why, then that just makes everything easier to remember. So how do you multiply two two-digit integers, like 48 times 19? Let's first define AB with a bar as meaning 10A plus B, where A is in the tens place and B is in the units place. AB times CD is equal to A times, so first we start from the right and we move our way to the left. So B times D would go into the units place. A times D plus B times C would go into the tens, and A times C would go into the hundreds. Make sure to carry over. So what's 27 times 19? Okay. For this one, I'm going to go here and so 27 times 19. First, we multiply 7 by 9. We get 63. So we put our units digit there. Then we multiply in with out. So 2 is one of the outer numbers. We multiply out, and in, which means that we multiply these two, which are in the inside of these 4 digits, and we multiply those two. So 2 times 9 plus 1 times 7, we get 25. But we also have to carry over this 6. So we get 31. And we put 1 in the tens digit. Then we multiply the tens digit. We get 2 times 1 plus 3, which is equal to 5. And that's our answer. Does that make sense? Okay, then we're gonna move on to some practice. You can only use mental math, and if you have questions, you can private message me. Okay, now we're going to go on to the answers. If you want me to slow down, then I can. Nine 12, 493, 1776, and 2958. Okay, now we're going to go on to some specific multiplication cases like multiplying by 25. So you can multiply 18 by 25 using the previous method and get 450, but 25 is a special number. It's equal to 100 divided by 4. So we can write 18 times 25 as 18 divided by 4 times 100, which is 18 over 4 is 4.5. Now 4.5 times 100 is 450. So try and solve these problems on your own. All right, we're gonna look at the answers. 675, 1800, 2450, 1075. And multiplying by 50 is similar but much simpler. So you can divide by 2, and then multiply by 100. So something like 48 times 50 would just be 2400. Okay, what if we multiply by 99? To multiply by 99, we multiply a number by 100 and subtract that number from the 100 times that number. So 84 times 99 is equal to 84 times 100 minus 84, and we get 8,316. So we're just going to do practice. And again, if you have any questions or if you don't understand why something works, then you can always ask. Okay, it's 56, 43, and 48, 51. So what if we multiply numbers close to but less than 100? 98 times 96 can be solved by our method in 1.1, but we have a simpler way. First, we find the difference from 100 from both of these numbers. 100 minus 98 equals to 2, and 100 minus 96 equals to 4. We multiply these numbers to get the units digit. Now, whatever our product is of the differences from 100, we put those using 2 places, the tens and the units. So because 2 times 4 equals to 8, our number will be something, something, 08. Then we subtract the difference from one number from the other number. So the difference from 96 to 100 is 4. So then we subtract 98 minus 4, which is our hundreds, our thousands and hundreds digits. So we get 9,408. So solve these methods. All right. 93 times 91 is 8,463. 89 times 98 is 8,722. 95 times 92 is 8,740. 99 times 97 is 9603. Again, doing these problems will help you if you just try and look at them, look at the methods without doing them, then it just doesn't really help. Okay, so what if we multiply numbers close to but above 100? Our last one was less than 100, so what about above? So like, what if we take 103 times 108? Well, we can do something similar. So we take the difference from 100, which in this time is 3 times 8. And again, we let it take 2 places. So it's something, 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 2, 4. That's our answer. Then we add the differences, so we get 11. And then we have to add a 1 in front. So you get 11,124. So we have 3 practice problems. Okay, so 5.3, we get 10,710. Then we get 11,227. And this one is more of a tricky one because 12 times 15 is equal to 180, but because it only takes up 2 places, we have to carry 1 over to 27, and we get 128.80. Now we multiply one number that's close to 100 but less than it. Now we multiply one number that's above 100 but that's close to it. So try and solve a problem like 96 times 103. Let's say the number less than 100 is 100 minus 8, and the number above 100 is 100 plus b. The tens and units digit is 100 minus a times b. So for this one, it would be 4 times 3, that's 12. 100 minus 12 is 88. The thousands and, oh, sorry, I meant to say hundreds digits are the number that's above 100 minus a minus 1. So for 96 times 103, that would be 103 minus 4 minus 1. So our answer is 9,888. Okay, now let's do some practice. If you are confused as to why this one works, you can ask me. So we get those numbers. Oh, sorry. I didn't see your message. Which page do you want me to go back to? Okay, well, if you want me to go back, you can. Okay. So those are our answers. And we'll go on to the next one. So what if we multiply by 11? Like 23 times 11. Well, the units digit is 3 because 3 times 1 is 3. The tens digit is 5 because we add 2 and 3. The hundreds digit is 2. In other words, add up adjacent digits to get the digit of the higher place. So something like 92 times 11, you can practice with these. Is everyone set to check out the answers? Okay. Okay, now we multiply by 111. It is fairly similar to multiplying by 11, but this time you add up 3 numbers. So for example, to find the units digit of 327, we know that's just 7. The tens digit, we add 2 and 7. The hundreds digit, we add 3, 2, and 7. The thousands digit, we add 3 and 2. The 10,000s digit, we add 3. And that's our answer. Does this make sense? Okay. All right, so those are our answers, and I will be sharing the slide at the end. Okay, now we multiply by 37. So I'm going to let y'all try it, and then I'll reveal the answer. 12 times 37. You can use a method from 1.1, or you can try and find a different way about thinking. Okay, so 37 is equal to 111 divided by 3. So 12 times 37 is equal to 12 divided by 3 times 111, which is equal to 4 times 111, which is equal to 444. So now try and solve those problems. Oh, I thought I'd changed to these, but I guess not. Do those instead. Okay, so yeah, just ignore these, but the answer is to 27 times 37, that's 999. 93 times 37, that's 3,441. 48 times 37 is 17,076. I mean, 1,776. Okay, so this is a terminology thing. What are triangular numbers? We might see problems like find the first triangular number. Let's define T1 as the first triangular number and Tn as the nth triangular number. Tn is equal to n plus 1 times n divided by 2. So the fourth triangular number is 4 times 5 divided by 2, which is equal to 10. So let's prove that T of n is equal to n plus 1 times n over 2. Let's first look at the geometric interpretation. So T of 1 is just 1. T of 2 is a triangle because it's a triangular number with 2 circles on each side. T3, T4, T5, T6. So T of n is equal to 1 plus 2 plus 3 plus all the way to n, because on each new layer you add n. So that is equal to the average times the number of numbers, which is n plus 1 over 2 times n. So let's just practice those numbers. And we get 15 and 55. Let's go on to polygonal numbers. So this is similar to triangular numbers, but a quote from Wikipedia. In mathematics, a polygonal number is a number represented by dots or pebbles arranged in the shape of a regular polygon. The nth polygonal number simply means that the side lengths have n dots. So the picture to the right is the second pentagonal number. If S is the number of sides in a polygon, then the formula for the nth esgonal number, P, is S minus 2, which is the number of sides minus 2, times n minus 1 over 2 plus n. So you can see that if S is equal to 3, then we get the formula we established in 10.1. And the proof of this is pretty difficult. Many proofs use calculus or difficult concepts, so I would just, this is one of the few that I would just recommend learning the formula for. So find the sixth pentagon. Make sure you see this. It's S minus 2 times n minus 1 over 2 plus n. So find the sixth pentagonal number, 10th decagonal number, 18th square number, and the third heptagonal number. Okay. The sixth pentagonal number is 51. 10th decagonal number is 370. 18th square number, if you use the geometric interpretation, you know that it means that it has 18 dots on each of its sides, which means that it has 18 times 18, which is 324 dots. You could also use the formula, but I think this one's easier. And then you can go on to the third heptagonal number, which is just 18. So an important part will be Roman numerals. They'll ask you about this in calculator number sense, really a lot of competition. So they'll test you on Roman numerals. So it's best to memorize them and know how they work. Let's look at the chart. I is equal to 1, 2 i's is equal to 2, 3 i's is equal to 3. V is equal to 5, x equals to 10. L is equal to 50, not 40. C is equal to 100, D is equal to 500, and M is equal to 1000. By putting a bar over any of these letters except I, such as D with a bar on top of it, it will multiply it by 1000. So for example, L with a bar on top would be 50,000. So if we want to write a number like 6, we can break it down. 6 equals to 5 plus 1, so you write it as VI. 7 is equal to VII, 13 is equal to XII, 1233 is equal to MCC XXX III. But what do we do for something like 9 or 490? 9 is equal to 10 minus 1. So if we want to subtract a smaller number from a larger one, we write the smaller one in front. So 9 is equal to IX. 490 is equal to CD. That's how we get 400. But we also need to get 90. And 90 is equal to 100 minus 10. So that's XC. 900 is equal to CM. Because that's 1000 minus 100. 29 is equal to 30 minus 1. So we put an I in front of the last X. So that's XXIX. 39 is equal to XXXIX. 400 is equal to CD. 989 is equal to 900, which we get from CM. But we need 89, so we get LXXX. And then to get the 9, we get IX. So how do we write 495? Really simple way would be writing CD, because D is 500. I mean VD, because V is 5, D is 500. 500 minus 5 is 495. But we can only write C in front of D and M, X in front of C and L, and I in front of X or V. So we can't write V in front of anything. So let's practice converting these numbers to Roman numerals. Okay, we're running out of time, so just convert the first three. Okay, so we get XXV, DCCC, XCII, MCM, XXV, II. All right, now let's practice converting from or into Arabic numbers, which are the ones we use now. All right, so we have 90, 43, 164, and 440. So now I'm just going to give a few more tips. So first, practice is really important. That's why I included a lot of examples. That's how it becomes easier to do in your head. You also want to know why these tricks work. If you have any questions, then I can always explain them. Now, you also want to memorize a few things. That's kind of annoying, but it really will help. So memorize squares 1 to 40, cubes 1 to 20. No notations like unions, intersections, etc. Know what things like hexagonal or decagon or dodecagon mean. And I can answer some more questions if you want to know things about dates, time, proper fractions, GCD, unions, intersections, etc. All right. I guess I'll just go over a few things from the test that I didn't really include. You can leave now if you want. This is just going to be some extra stuff, but yeah. So for things like this, you have to know what specific remainder rules are. So dividing by 2 is simple. Dividing by 3 is you add the digits and then you find the remainder of that. So like if you wanted to find 532, that would be 5 plus 3 plus 2, which means you have 10, so it has a remainder of 1. For 4, you just find it from the last two. For 5, just use the last digit. For 6, you do something similar to, you find the remainder in 2 and 3, and so like let's use 174. 174 is 2 in mode is 174 is divisible by 2, and it's also divisible by 3, so 174 is 0 in mode 6. If you divide by 7, you can multiply the last digit by 2 and subtract it from the rest. You can do that as many times as you want. For dividing by 8, you look at the last 3 digits. For dividing by 9, you add the digits, like how you do it at 3, and then you divide, and then you just see what the remainder of that number is. 10 is just the last digit, and 11, all you need to do is you add the numbers in alternating orders and you subtract them. So let's say if you have number 145, you add 1 plus 5 minus 4, which means that it would have a remainder of 2. Let's say you have this huge number, you don't want to divide that. So what you can do is 7 plus 2 plus 1 minus 8 minus 8, and that becomes the remainder. So does anybody have any questions? If not, you all can leave. I'm gonna just post this. If you have anything that wasn't clear, you can always just go there. If you have no more questions, then you all can leave.